Hello, my name is Trevor Noren, Investment Communication Strategist with Wellington. For 40 years, Future Themes has been instrumental in shaping the firm's long-term investment outlook. The question at the heart of the initiative has been a constant. What are the trend lines that will define markets, societies, and economies over the next 5 to 10 years? Future Themes leverages the firm's breadth of expertise to find answers and deliver actionable insights. The research is done, and now it's time to present. We kicked off with a sit-down with Dara Dunn, the leader of this iteration of Future Themes. He and I discussed the architecture of the research effort and the key insights from each of our 4 areas of focus, the 4 S's: sustainability, systems, society, and science. Over the last few weeks, we've drilled down into our first 3 S's. Today, we tackle the final S, science. Fear around automation has been escalating for years as a wage stagnator and job destroyer. Yet from enterprise automation to factory automation to medical automation, advancements in robotics and artificial intelligence also promise to advance global quality of life and life expectancy. How do innovators both drive progress while ensuring benefits are distributed equitably and global workers are not disenfranchised? It's a question vital to future investment returns and the stability and vitality of economies and societies around the world. Luckily, we've brought together an incredible collection of experts to offer guidance. With that, I'll turn it over to you, Victor.
Thank you, Trevor. I'm Victor Cherian. I'm a global industry analyst in the Singapore office, and I'm joined by my colleague David, who works in our London office. And together we are going to talk about the factory automation theme that we worked on. So I've been a big believer in the factory automation theme, primarily through my role as a global industry analyst, but also through a passion of mine in personal capacity. I've always believed that we were at this Cambrian moment for factory automation. And then the pandemic happened, which took it to a new level. So it was fun being associated with the project because we got to spend time doing a deep dive on things that would catalyze the growth of factory automation over the next 5 or 10 years. So we approached this project in 3 dimensions. One was to think of what needs to happen to catalyze automation adoption to a higher degree on factory floors. Second, to think about how business models evolve as we go through this process for the players and even the suppliers. And the third was to just think about the broader ramifications of society and the economy and what it does for society, governments, jobs, etc. So I'm going to spend a bit of time on the first 2 areas, and then I'm going to get in my colleague David, who has some interesting thoughts on the last area. So in terms of what needs to happen to catalyze adoption, it might sound trivial, but the reality is that despite all the advances we've had in automation, the amount of penetration on factory floors remains abysmally low. For instance, from the beginning of time, we've only had about 3.5 million robots installed on factory floors around the world, which, when you think about it, is a very small number. So the first dimension was trying to understand what is it that enterprises are looking for that would foster greater adoption. And what was perplexing to us was that we are at a point where there's a convergence of a number of different technologies. You have big data, AI and machine learning, quantum computing, and then virtual reality and augmented reality as well. But yet the adoption has been a bit slow. And there are 2 things that came up from our research that were pretty interesting. One, which was anecdotally evident in hindsight, was just the user interfaces. The industry so far has done a pretty poor job of making user interfaces easier to deal with. And that's been a big challenge for new workforce coming on the factory floors. There's a pretty interesting anecdote here. The average American teenager today spends about 10 to 15% of their time playing video games. And so when they come into the workforce and they've got to deal with this clunky industrial robot, it becomes very non-intuitive for them to work with this interface. And so having to take workers off the factory floor, retrain them for weeks and sometimes months, has been a big impediment because there is an ROI implication for all of this. The one other interesting area was mobility. And that's another interesting area because, when you think about it, the ability to have an untethered robot on a factory floor opens up a number of other degrees of freedom. It helps make your manufacturing process very flexible. And that can be a big advantage and a huge return for the customers. I think later on, David's going to talk about 3D printing in the context of flexible manufacturing, which is also another technology that we are pretty positive on. The second area we spend time on was trying to understand how business models evolve for companies that are involved in this space. And there are a couple of things that came out from our research. One, the importance of software. And the importance of software in not just being a table stake, but something that can be monetized over time. Today there are a number of software applications, but they've not evolved to the point where the customer feels compelled to pay for them. But we see a number of emerging technologies on the horizon, especially with deployment of technologies like augmented reality and virtual reality, which could make this a very compelling proposition, in addition to present solutions like predictive maintenance, the digital twin, etc. And I think this leads us to our second conclusion, which is the importance of software is going to force greater consolidation across the stack. Meaning, over time, we will see more and more instances of companies dominant in hardware acquiring software companies, fostering partnerships with software companies, or even to a lesser extent, maybe getting involved in the software design themselves. And that's a trend we are going to see emerge pretty strongly in maybe in the latter half of the coming decade. So I'm going to pause there and bring in my colleague David, who spent a lot of time for the team on the implications of the growth in factory automation for society as a whole. So David, if I can just ask you, from a very top-down perspective, big picture, how do you see the world changing as factory automation evolves? How do you think about the impacts on the economy and society?
Well, thanks, Victor. As with any industrial revolution, and many people would categorize this as one, there are likely to be profound impacts on the economy and society. At a commercial level, we think there's going to be some significant changes to business models. Smart manufacturing is about having true autonomous adaptability for manufacturing systems, not merely digitizing existing processes. And that is a big step forward for sure. We're likely to see a rise in so-called product service systems, where manufactured goods are produced as part of a service, and supply chains become much more directly integrated into the business of a client. And as these smart manufacturing ecosystems emerge, I think we're likely to see new network effects develop, which can bring new economies of scale and raise barriers to entry for players who aren't part of those ecosystems. The competitive advantage is naturally going to be shifting more and more towards software IP from hardware and other factors. But this isn't going to be an instant process by any means. It may well play out quite differently to the way that we've seen technology disrupt so many other sectors, because the technical expertise of the existing players will still remain valuable, meaning that there's going to be a better chance for these new ecosystems to grow up around existing incumbents, even if the spark of innovation comes from a new disruptive source.
So, are we seeing any changes in reality?
Absolutely. We're already seeing changes on the ground, but it's got a lot further to go. One example of this, which you mentioned earlier, is additive manufacturing, or 3D printing as it's more commonly known. And that's something that's really been enabled by more advanced automation technology. Although it's often portrayed as a niche activity, it's actually being taken up by many different firms at a commercial scale. It's really a new class of manufactured product. Most items historically are either forged into shape or cut down from larger pieces of material. But building up a component from the ground up allows entirely different shapes to be produced, with more efficient use of materials and completely different functionalities. And these components, made from metals and plastic and a variety of other substrates, are going into aircraft and automobiles already today. But perhaps most profoundly, it's also very flexible. We're all very familiar with economies of scale, where the marginal cost of producing each incremental identical item gets cheaper and cheaper. But technologies like additive manufacturing open up economies of scope, where you can produce different items on the same line and still reduce marginal costs. And that's going to really blur the lines between prototyping and manufacturing, and opens up the possibility of much more custom output than we're historically used to.
So, David, what does all this mean for the economy?
Well, the potential first-order effects are not that hard to guess, although the scale of the impact remains very uncertain. We will see a boost to GDP growth over time. We will see improved productivity and wages. And inflation could remain more subdued than it would otherwise be, as more efficient use is made of the key inputs into production. And this could produce quite different outcomes depending on where in the world you are. If, for example, you're in an emerging market that's planning to develop by building up a textile industry, which is something that many countries have done before, then you might be looking at the new generation of robots that can handle soft, pliable materials like cotton fabric and make a dozen shirts in an hour. And that could be a concern to you over what it means for your economic convergence. On the other hand, if you're a developed market with aging demographics, a shrinking workforce, then advanced automation could be a really valuable tool to sustain your economic growth.
On your last point, David, don't you think automation is a problem for jobs?
This is a pretty controversial area, and you're right to raise it, Victor. But the empirical evidence for what I would call neo-Luddism is actually quite poor. The historical evidence is that unmet demand can be tapped. The unmet demand that can be tapped by more efficient automated production is often greater than the unit labor efficiencies. And what that means in practice is, for example, vastly more people are involved in automobile manufacturing now when it's highly automated than when coach builders were creating them by hand. And the same is true of many other industries like steel, for example, or textiles. But I would say that the evidence around wages is more mixed. Although wages in general will increase, there are going to be winners and losers in any industrial transition. And there can be a significant difference between the experience of the mean average worker and the median average worker as a result of unequal distribution of any value that's generated. And that issue of inequality may be somewhat more powerful this time around because whilst robots were previously replacing humans in jobs that were difficult or dirty or dangerous, nowadays, thanks to technologies like AI, robots are simply able to replace more of what humans can do. And that's just going to keep increasing as technology advances. But overall, I think we should be optimistic about what automation can do for living standards. As long as markets are competitive, most of the value created is ultimately going to flow to the consumer in the form of cheaper and better products. And in particular, we have the potential to enjoy a much more bespoke method of consumption with a greater variety of goods than ever before.
Yeah, I think the impact on jobs could be a controversial area indeed. How do you think governments will react to this?
Well, there's a lot of discussion about robot taxes these days, but practically that's something that's really problematic to implement. For example, even the basic question of what a robot is can be difficult to answer. We all have phones now, and they're capable of interacting with the physical world through sensors and automatically processing things to produce output. So are all our phones robots, for example? And a robot tax can also suppress innovation. And that's very problematic because any country that can't move with these advances is going to fall behind. But there could potentially be political arguments around boosting redistribution more generally, and perhaps preferencing labour over capital. We're definitely a long, long way from the so-called post-scarcity economy. But perhaps we should be making sure that our grandchildren are familiar with Karl Marx as well as Isaac Asimov.
Thanks, David. We're really set for very interesting times ahead. With that, I'm going to hand it over to Adam for the next piece in the science stream. Over to you, Adam.
Thank you, Victor, and thank you everyone for joining us today for the medical automation portion of Future Themes. I'm Adam Ilfelder, Equity Portfolio Manager here at Wellington, and I'm joined today by Silas Brown, equity analyst. When we started to think about automation within the healthcare industry, we initially focused on the increasing pervasiveness of genetic testing and the power of genomic sequencing. And what we quickly realized was that the downstream impacts of this trend could potentially revolutionize the therapeutic industry of drug development. Finally, we tried to consider the potential ramifications of this trend on costs in the healthcare system. As if we were seeing increasing treatments for rare diseases that currently cost hundreds of thousands, if not millions of dollars, what would happen if we were to increase exponentially when we treat ever more rare diseases? In addition, we also needed to consider what the impact could be as the technology addresses more mainstream diseases. So I'd love to bring in Silas here to discuss the innovation in human genome sequencing. Silas?
Let's start our discussion by going back to the sequencing of the first human genome and bring that forward to where we are today. The Human Genome Project started in 1990 and took 13 years and $2.7 billion to sequence the first human genome. Since that time, the technology has advanced rapidly, and today, a genome can be sequenced in just over a day for just under $600. The dramatic decrease in the cost of sequencing has enabled a huge expansion in the ability to sequence human genomes. Recall that a human genome has over 3 billion base pairs and that every person is different. So starting in the early 2000s with the first human genome, researchers have now sequenced over 1 million human genomes. We are still very much in the early stages of the discovery and application of that research into clinical practice. In terms of research, genome sequencing has enabled greater understanding of rare diseases and cancers. We are now able to apply those lessons to diagnose patients earlier and develop new targeted therapeutics.
That's great, Silas. And in our research, we found that the first place where this research has started to translate into the clinic is rare diseases. But first, let's start with a quick definition. Rare diseases are diseases that affect fewer than 200,000 people. And so this seems like a small problem, but when we combine that with the fact that over 7,000 rare diseases have been identified, it means that an estimated 30 million Americans are affected by rare diseases. And this holds true globally as well, where it's estimated that between 10 and 20% of the world's population has a rare disease. Historically, it could take as long as 5 years to diagnose a patient with a rare disease. But due to the advances in the speed of sequencing a human genome and the much lower cost that Silas mentioned, physicians are now able to diagnose patients more quickly and more accurately. Silas, can you share a few ways that this testing is being implemented in the real world today?
Absolutely. An interesting place to start might be how genetic testing is impacting maternal and fetal health care. Today, couples seeking to have a child can have their DNA sequenced to test if they are carriers of rare genetic disorders, to understand the likelihood of passing on that rare genetic condition to their future offspring. If the prospective parents are carriers, they can have pre-implantation screening done to test an embryo's DNA so that only healthy embryos are implanted. And once a fetus is 12 weeks post-conception, physicians are able to draw a vial of blood from the expecting mother and separate the mother's DNA from the fetal DNA to screen for certain genetic defects in the fetus. This last innovation, called non-invasive prenatal testing, has spawned a new possibility. When Illumina was developing their non-invasive prenatal test, they infrequently saw that they were detecting the mother's DNA, the fetus's DNA, and a third DNA not associated with the fetus. Upon investigating this third source of DNA, they realized that they were actually detecting DNA that was being shed by a tumor that the mother was unaware that she had. This realization that scientists can detect cancer in a person who does not have any symptoms of a blood test is incredible. This sounds futuristic, but the first commercial test that can detect 50 different types of cancers is launching as we speak. This is still an emerging technology, and we expect that the accuracy of these tests, as well as the number of types of cancers that they can detect, will increase over time. We can stay on the topic of finding little pieces of DNA that cancer has shed into a patient's blood and apply that to patients who have already had cancer or who are currently being treated for cancer. Today, blood tests are available to determine if a patient is responding to a therapy, as well as to see if a patient that is in remission, that their tumor begins to grow. Finally, physicians can use genetic sequencing to identify specific drivers of a cancer and determine the most effective therapy or combination of therapies. This knowledge can be also used to develop new therapies as well as enrolling clinical trials.
And so just to put a finer point on the investment conclusions from these innovations, the first big takeaway is that we're still very early in both the research and the application of genetic testing, and we expect significant growth in this market. While there will be winners and losers along the way, it's very important to recognize that we do not think that this market is zero-sum. We do see the life science tools and diagnostic businesses as well positioned to benefit from the growing genetic research and testing market. All right, with that, let's transition to talk about how this knowledge is being applied to develop therapies for both rare diseases as well as cancer. Silas, can you talk about how this knowledge is impacting an emerging therapeutic modality known as gene therapy?
It may be helpful to go back in time and start with the first approved gene therapy, how it is, what it is, how it works, and how its development sets the stage for future therapies. The FDA approved the first gene therapy in 2017, marking the end of a 20-year process from discovery to approval. This drug, Luxturna, corrects a genetic mutation in the RPE65 gene. This gene converts light into the electrical signals that the brain converts into sight. When a patient has mutations in both copies of their RPE65 gene, they are nearly blind, with severely restricted field of vision and lack of visual acuity. Scientists create corrected copies of the RPE65 gene and then insert those genes into a virus. The virus is then injected into a patient's eye. Once inside the patient's eye, the virus then carries the corrected genes into the patient's cells, and the cells return to normal function. This life-altering therapy is priced at $850,000 in the United States. And while the price is high, it has to be weighed against the relatively small patient population, perhaps 6,000 people in the United States, Europe, and developed Asia, as well as against the potential for a lifetime of sight.
Luxturna is an amazing proof of concept, allowing people to see the promise of gene therapy. But it's for a very rare genetic mutation. So we were really interested in exploring sickle cell anemia as the potential first opportunity for gene therapy to impact a much bigger population. Severe sickle cell anemia patients have a devastating disease, and it affects tens of thousands of African Americans. Like in the case of Luxturna, the most severely affected individuals carry mutations in both copies of their genes. These individuals face numerous painful crises each year and have a median life expectancy of only 45 years. The only curative treatment currently is bone marrow transplantation, but that's actually limited to individuals who have a sibling that is a matched donor. There are now 3 different companies that are actively enrolling patients in clinical trials to replace the defective part of the human hemoglobin gene with a corrective copy. Interestingly, these companies are tackling the problem through 2 distinct pathways, and the early work does suggest a really effective and durable treatment. The trials are ongoing, but with luck we could see approval in the mid-2020s. Because these therapies are not yet approved, the companies have not really commented on potential pricing. However, Bluebird does have a similar gene therapy that treats a related condition known as beta thalassemia, and it's approved in Europe. It has a price that's actually almost 1.6 million euros, but it's paid out in equal installments over 5 years. One of the interesting things that we found, though, is that only the first payment is actually guaranteed. The remaining 4 payments are made annually if the patient meets certain outcomes. But this is really just the beginning of a new frontier of treatment. Each year, we expect to see more potential therapies beginning clinical trials, and while not all will work, the FDA expects that 10 to up to 25 new gene therapies could be approved annually by the mid-2020s. Now, while the potential for these therapies may be life-changing, as we described before, we also mentioned that the initial indication of cost looks really high. So Silas mentioned $850,000 for Luxturna, and as I mentioned for the beta thalassemia treatment, 1.6 million euros. Silas, can you share what our research showed in terms of how payers are responding to this and what the price could potentially be as a barrier to adoption?
This is a great question, and it will probably depend on a few factors. The first is obviously the price of the therapy and the total number of people that would be affected. When you combine that, you can determine the total cost of therapy on the society. Another factor could be geography or the type of healthcare system, where different systems have different incentives or perspectives on the total lifetime cost of a disease versus the cost of a therapy. Our team expects many single-payer country systems outside of the United States to continue their traditional process of direct negotiation with biopharmaceutical companies to arrive at a price. Single-payer systems may have several advantages when thinking about expensive but potentially curative treatments. The single-payer system will likely have long-term cost savings by curing these patients, but there will be a mismatch between the timing of the costs and the benefits incurred. The United States, through CMS and other pilot state programs, could try to enter direct negotiations with biopharmaceutical companies, but we expect this to be the exception. We expect biopharma companies will be required to show meaningful and durable benefits to the quality of life and for that data to be used in cost effectiveness analysis. We expect both single payers as well as US commercial insurers to lean on this data to drive pricing and coverage decisions. Finally, we expect the free market to have a meaningful impact on the pricing of these therapies. Because these treatments are potentially curative, there could be a race to treat these patients that could lead to significant discounting among potential biopharma companies. There may also be more ways to treat these patients via multiple gene therapy modalities, leading to more potential competitors, as we are seeing in the sickle cell case. Finally, there may be other modalities enabled by this pioneering genetic research, where gene therapies will have to compete in terms of cost effectiveness with small molecules, biologic drugs, or other forms of treatment.
Thanks so much, Silas. At this point, I'd like to summarize this part of our discussion by sharing several important considerations when thinking about investing in these transformative therapies. First is that the timeline of approval of gene therapies may be longer and is more uncertain than other therapies. This is driven by several factors. The novelty of these treatments means that regulators and companies are still searching for ways to standardize the trial and approval process. The manufacturing of these drugs is a much greater challenge than any historical drug production we've seen. And finally, reimbursement for a potentially curative treatment is a new paradigm that the current system is not optimized for. We do believe that as the companies, regulators, supply chains, and payers gain experience with these new forms of treatment, the risk and timelines will come down. But it's prudent to be both excited by the progress made in the first few patients that are dosed with the new therapy, but also cautious on the time and cost of bringing these drugs to market. I'd now like to turn it over to Yaro Pan to discuss enterprise automation.
Welcome to the discussion of the future of enterprise automation. Today we will share our perspective on three key aspects: how work gets done, how we communicate, and how we store data. But first, introductions. My name is Yaro Pan. I'm an equity research analyst on the Global Opportunities team. I focus on how technology trends shape our global opportunity set. I prioritize understanding the major platform shifts that have a lasting effect on our investment landscape. I'm joined by Ben Kibler. Ben, could you please share your background?
Thanks, Yaro. My name is Ben Kibler. I'm an IT architect working in our investment science group. I help with the engineering and infrastructure needs of our data scientists and quantitative investors. My team works a lot with natural language processing and machine learning and applying that to the investment process. Prior to my role in investment science, I led our central IT engineering team, where I was responsible for our transition to the cloud and also for the creation of our enterprise data lake.
Thanks, Ben. Well, before we dive into all the research topics, would you mind maybe highlighting one or two key technologies that stood out to you in our research?
Sure. So the first one we're going to talk about is low code and how I think that is the spreadsheet of the next generation. And the second topic is databases and how they're evolving to fit into the new world of cloud computing. How about you, Yaro? What stands out to you?
For me, Ben, it's really about bots and how our relationship with them redefines how we work and our relationship with software. So we will just dive in and bridge a connection between that and some of the other concepts that you talked about. One of the important developments that we researched here at this project was the evolution of AI and particularly the capabilities around language and vision understanding. I think what we're seeing is pretty significant breakthroughs in bots' abilities to understand all of those inputs. One of the important recent concepts in enterprise automation is robotic process automation. And robotic process automation represents the ability of bots to replicate human actions. And robotic process automation, in a way, sits as a gateway for which we interact with a lot of applications that already exist. Maybe, Ben, you could share some of your perspectives on this technology and how it fits within the enterprise landscape.
So, as you mentioned, RPA is really about automating human interactions, and I think of those as analog interactions. Open a window, copy and paste some text, click a button, got to get an error message or a confirmation dialog. And the competitive advantage that RPA vendors have is they've built up this inventory over many years and thousands of applications, legacy ERP systems, and they know how to interact with those systems in an analog mode as a human would. An analogy that we can use is the check scanning app on your mobile phone. This is an analog process. You scribble some names and numbers on a piece of paper, put it in an envelope, you send it to someone else, and they use the check scanning app to reverse engineer the name, the number, the date, and then that eventually turns into a monetary transfer. But imagine if we could move the money digitally, if we could electronically move the money from my account to your account without needing to reverse engineer what you scratched on a piece of paper. And I think that's the future. The future is about APIs, so the ability to interact digitally through a machine-readable interface and automating those digital interactions. If application capabilities are now machine-readable and discoverable, and data is available in a shared data platform, and we'll talk more about that, what if we could build an automation framework that the average knowledge worker could use to interact with all those capabilities? And that's what low code is. Low code is a way for your average knowledge worker to take a look at their business process and leverage all this data and all of these machine learning capabilities and tie them together in a simple toolkit without needing to get into the weeds of low-level programming and without needing all of those IT programming resources.
Yeah, I think the aspect of the low code that you really emphasized in this project, Ben, the ability of workers without sophisticated IT skills to have access to automation tools that they previously hadn't had before. That's a really interesting kind of aspect of the future of automation that we think is really, really important. And bots play a big role in simplifying that. Bots act kind of like a virtual translator from human to machine code. They serve as that interpreter for us to access really complicated technology. There are interesting companies that are emerging at the intersection of these technologies to really bring it to market. But also we feel like it has an impact on the competitive advantage of existing software vendors. The software vendors that have easier tools that take advantage of these technologies, we feel have an advantage over others that have really complex and difficult integrations. And also as companies approach digital transformation, it's important for them to think about what is the right organizational structure with which to approach these projects. And maybe, Ben, you could share a perspective of how you think the organizational structure needs to evolve to really capitalize on these tools.
A lot of the work we do in investment science really is a form of low code. We take all this vast amount of information that we have, and then we marry it up with the natural language processing capabilities, machine learning APIs, and we make it available to investors in a very simple scripting environment with little or no coding. We're not giving investors the answer, and we're not giving them a no-code solution. What we're doing is we're giving them a toolkit that they can integrate into their workflow. In the same way that spreadsheets allowed knowledge workers of the previous decades to tap into data and compute resources without having to write code, low code is how we expose all of these capabilities and all of this data to our investors for the decades to come. And rather than divide the world into two discrete camps, the programmers and the non-programmers, we think of it as a continuum. There are on the extreme people who are engineers and hardcore coders, and there are people who will probably never write any code. But in the middle, there are a lot of people who would have traditionally written formulas in a spreadsheet, and they're not programmers, but we do think with these low-code solutions, they can pull together all of these capabilities and integrate them into their research workflow. And this was accelerated quite a bit during the pandemic. So Yara, could you talk more about how the pandemic accelerated this?
Yeah, Ben, right as we were working on this project, we were in the midst of this pretty unprecedented time. And what we did see is we saw accelerated adoption of a lot of these technologies. IT teams were stretched, and companies were trying to find other ways that workers can automate their work. In collaboration, we obviously had to shift to very different modes of connecting with each other. And we do see a much more lasting impact of this. We see years of innovation being pulled forward. And there's a lot of innovation around new formats through which we collaborate. There's new attempts to see if we can collaborate in virtual worlds. There's new audio-only formats that are emerging. So I think in the years ahead, we see a lot of continued innovation in how we connect digitally and how automation helps us achieve that. Ben, could you please share some perspectives on how you see collaboration evolving in the enterprise?
So a lot of the conversations that used to happen offline, so in an elevator, at someone's desk, maybe in a conference room talking face to face, those conversations are now captured digitally. Now we have all this information from chats, transcripts that we can apply machine learning and natural language processing to and find insights and patterns. We can find islands of communication, two groups that are talking about the same thing, but maybe those two groups have never talked to each other. We have amazing opportunities to break down information silos as we digitize more and more of our collaboration. As more and more of these collaboration patterns happen in the same platform on a single vendor solution, it's much easier to have comprehensive insights across email, chat, scheduling, notes, documents. The knowledge graph that you can build when all of these digital artifacts are in the same place is really amazing. So one of the questions that I have is, how do point solutions and innovative niche vendors, how do they find a place in this future marketplace?
Yes, Ben, the topic of who wins in the collaboration software space is a really debatable topic, and we spent a lot of the time on the team exploring that. One of the strategies that point solutions that are really strong in one mode of communication, like video, can take is really make sure that the network effects outside the company walls are as strong as possible. So we see opportunity for vendors to approach that market with that competitive advantage in mind. We also see new formats emerging, and it's really up for grabs about which companies succeed in audio-only or virtual world formats and whether existing vendors can capitalize on those technologies. But overall, collaboration is highly strategic. As Ben mentioned, the data in the collaboration apps is very valuable. And in the future, we also expect bots to play a bigger role in collaboration. For instance, there's more and more virtual meetings that are now available to attend. At what point will it become acceptable to send a bot to attend the meeting on your behalf? Part of it is also not just technology challenge, but social acceptance challenge. Another aspect of our interaction with bots for collaboration is just how we think about application design in the future. For example, in the future, HR onboarding may involve just an interaction with the bot in a chat window rather than logging into an application to fill out various forms. And for these reasons, it's going to be important to understand who succeeds in the enterprise and becomes leaders in collaboration. But all this innovation rests on the data and how we store data and how we address its security and regulatory needs is an important aspect of the future of enterprise automation. Ben, maybe you could share your perspective on how you think that evolves.
One of the biggest changes in the data landscape is just the sheer size of data. As we talked about all these collaboration data sets that are now available, these are giant data sets and they're often unstructured. And you need natural language processing to understand what's in the data. The other thing that's really changing is that data often doesn't live in your own data set anymore. It exists across multiple clouds, across multiple SaaS vendors, across your ecosystem of business partners. Data is no longer under your direct control. However, if you think about the security and regulatory changes that are happening, it's more important than ever that you be in control of your data and understand how that data is being accessed and used. And it's not enough to blame a vendor if they mishandle your data. So the real innovation that we see happening in the data landscape is around the next generation of cloud native databases that allow companies to share and collaborate on data without having to copy it around and have the data get out of your control. The data owner remains in control of the data, yet breaks down the silos in terms of how that data is shared across your vendor ecosystem. And these cloud database providers provide a very important security function, authenticating all of the different participants in that data exchange and acting as a control plane to make sure that the data is used appropriately. One technology that we think can be applied more in this next generation data platform is blockchain. So blockchain provides transparency and auditability, not only for the transactions, but what if we could apply that same level of transparency and auditability to how people access the data, the analysis that they perform on the data, and the results of that analysis. So in a world of zero trust, where you have to share your data with other cloud vendors and other business partners, what if you could audit how they accessed your data and the conclusions and the results of their analysis? Another driver is government regulation around supply chains and in particular ESG. So as you increasingly have to trace all of the carbon inputs to your business process and that information becomes digitized, imagine the opportunities for automation, efficiency, and analysis of that data as it becomes digital. So Yara, what are the investment implications of these data platforms?
Ben, all the technologies that you highlighted, particularly the ability to authenticate access to data in a very granular way and automate tracking its output, can really lead to new business models around data sharing. We talked about this a lot in the past, but this process has been cumbersome and difficult to deploy. But the next generation of databases are building out these capabilities and building out these governance tools to enable companies to really monetize the data that they have. And they can emerge as significant beneficiaries of blockchain technology over time. There are also investment opportunities in security software vendors as the world moves closer to that zero trust approach that you described. It's an approach that assumes that the perimeter of enterprise has been breached and tries to limit the impact of cyber threats within the organization. So overall, we see opportunities both on the database and on the security side. Just taking a step back and looking at the convergence of the technologies we discussed in this conversation, at the intersection of database and security technologies, we see emergence of new business models like data marketplaces. At the intersection of bots and collaboration, we see potentially new ways to design applications that don't involve you going to the application, but interacting with it naturally through a conversation. And At the start of the presentation, we talked about how the intersection of bots and low-code technologies really leads to that democratization of automation tools to a broader labor force, which we think will expand the opportunity set for automation and be more inclusive of a wider range of workers to take advantage of these tools. So in closing, maybe, Ben, could you please share one question that stuck with you after this project that you are thinking about?
For me, it's really the paradox of our data is scattered in increasingly more and more places. We have orders of magnitude more information, and yet we're expected to provide more control than ever over that data and how it's used. How about you, Yarrow?
For me, it's all about our relationship with bots and how it redefines our work in the future and what skills are needed to succeed in the future workplace. I'm also really interested in how our digital collaboration models evolve and make sure that the workplaces of the future are better for both workers and makes companies more productive as well. With all that, thank you very much for joining us today. I hope you found the content interesting and valuable. Goodbye.